and bases. So first of all, let's learn about acids. What are acids? So what do you think of when I say the word acids? We've actually discussed this before our lab lesson the other day, and some of y'all talk about corrosive, that is dangerous, or maybe like hydrochloric acid, citric acid are some of the acids that you know. Okay, now here's a story from World War One. In the past, Germans used chlorine gas as a weapon, and it caused a lot of deaths, mainly from respiratory problems. Do you know why that is so? Okay, at the end of the video, you will find out the answer. Okay, so acids are actually present in our everyday lives, even though the concentrated acids are dangerous. We have citric acid from lemons. Coca-Cola actually contains phosphoric acid, and vinegar contains acetic acid. Okay. Now, acids are even present in our bodies. Do you know where are they found? Okay, you may know that stomach has hydrochloric acid, or, or you may colloquially know it as stomach acid, but it's actually HCl. Okay, our proteins are made of something called amino acids. And even in our genes, it is made of DNA, which is also known as deoxyribonucleic acid. So, what is an acid? Can you copy down this definition? An acid is a substance that produces H plus ions when ionized in water. So, for example, this is your HCl. Okay, it is a covalent molecule. When we add it to water, it actually ionizes. Look at it carefully. You see that it becomes Cl minus, your chloride ions, and H plus ions. Okay, if I draw the Lewis diagram, how does it look like? Okay, so H has 1 valence electrons. Okay, H has 1 valence electron, and chlorine has 7. Remember, we consider hydrogen generally a non-matter. So non-matter and non-matter, it is a covalent bonding. But what happens when I put it in water? Okay, you'll see that my diagram would change. My Lewis diagram would change to H plus and Cl Cl minus, like so. Okay, so that's the difference here. In water, what happens is this chlorine will rip off both electrons, okay, and your hydrogen becomes just a proton. So that's what happens in water, and it is the H plus ion that gives an acid its acidic properties. Okay, so what are some examples of the acids that you need to know? Okay, can you copy down this again in your tables? Okay, you should know the formula of most of it. Phosphoric acid is a new one that you will see today. Okay, phosphoric acid. Note that the number of hydrogen that they produce is for each molecule is different. Okay, let's look at this ethanoic acid. You remember you said that it's very hard to memorize, and why do we write it as COOH instead of C2H4O2? Okay, now the reason is because this is what we call an acid group for organic compounds. Okay, only the hydrogen from the acid group will be ionized. Okay, the rest are still the covalent compound. Okay, now an acid has the following physical properties. First, it tastes sour. Okay, to help you remember, You can think of it as a lemon, lime, vinegar. They all taste sour, okay? But you don't have to drink the HCl in the lab to prove that it tastes sour, okay? And its pH is less than 7. pH is a measure of the concentration of hydrogen ions, okay? And we say that when pH is equals to 7, the solution is neutral, okay? An example of a neutral solution would be pure water, okay? That will be pH 7. So anything that's below pH 7, okay, so maybe I write down. Okay, so the lower the pH means the more acidic it is. The more acidic the solution. Okay, so water is at pH 7. If you have a solution of your HCl, the pH would definitely be less than 7, okay? Because a solution of HCl is more acidic than water, okay? What about when pH is more than 7? Okay, this is when we call it a basic solution, which we will learn about very soon. Okay, so next, an acid can also conduct electricity because when you are an acid, you have your ions H plus as well as your anion, let's say Cl minus for HCl, okay? And this ion, because they are charged, okay, they can conduct electricity. Now, it also turns the universal indicator to red or orange. The universal indicator is an indicator that we use to tell the acidity of a solution. Okay, it actually follows the color of the rainbow. So if you remember your colors of the rainbow: red, orange, yellow, green, blue, indigo, violet. So on the left hand side are the acidic colors. Okay, green being the middle color is when it's pH 7. Okay, let me just write it down too. Red, orange, yellow, green, blue, indigo, violet. Okay, see, green is in the middle, and this is when pH is 7. Okay, so here are your acidic colors, and here are your basic colors. So when the universal indicator is added to an acidic solution, it will turn red, orange, and yellow for the very slightly acidic ones. Okay, it also turns blue litmus paper red. Okay, that is something that we've discovered for carbon dioxide gas. Okay, it turns blue litmus paper red. Now, the last two, the use of indicators as well as the litmus paper, are actually tests for acids. Okay, now, what do you think will happen when I use blue litmus paper on solid citric acid? And what do you think will happen when I use blue litmus paper on citric acid solution? Pause and think for a while before I go on to reveal the answer. Now we move on from the physical to the chemical properties of an acid. An acid undergoes three general chemical reactions. First, when a metal is added to acid, we will get a salt as well as hydrogen gas produced. Okay, can you copy down your notes? The second reaction is when an acid is added to a metal carbonate and we have salt, water, and carbon dioxide. Last of all, we have acid plus base gives me salt and water. Take some time to copy down the answers into your notes. Okay, so acid metal gives me salt and hydrogen gas. How do we know that this reaction has occurred? Very simple. We do an identifying test for hydrogen gas. Okay, so if you recall, we actually did it in the lab during the practical. The lighted spleen will extinguish with a pop sound. Okay, it is important that you memorize this wording because it is specific to hydrogen gas. Okay, the evolution of not just hydrogen gas, actually any gas except for oxygen gas would extinguish the lighted spleen. Why is that so? Do you know what is needed to keep the flame burning? To keep something burning, okay, we need oxygen. Needs oxygen gas. Okay, so when there's another gas being evolved at a high concentration, okay, it will push away your oxygen gas. Okay, let's say a lot of H2 gas is being evolved. H2, H2, H2. So it pushes away your oxygen gas. And that's why your flame cannot burn anymore. That's why it extinguishes. But why does it pop? It is because hydrogen gas reacts with oxygen to give you water. Okay, if you recall, actually you've written this equation before. When hydrogen reacts with oxygen to give water, this is a very explosive reaction. Okay, so the pop that you hear is actually a mini explosion. Okay, so other gases, not just H2, even if carbon dioxide gas is produced, if I use a lighted spleen, it also pushes away oxygen gas and extinguishes the flame. But there will be no pop sound because carbon dioxide does not react with oxygen to produce anything. Okay? So that's why it is essential that you tell me that the flame is extinguished with the pop sound because otherwise I cannot tell that it's hydrogen gas. Okay, now next, how do we write an equation when given the reactants? Step 1, we need to determine the products. For instance, let's say hydrochloric acid and magnesium. How do I determine the product? I know that this is an acid metal reaction and I should get salt and hydrogen gas. So, hydrogen gas, I just write down first. How do I determine the salt? The anion comes from the acid, whereas the cation comes from the metal. So what do I mean? The salt would be magnesium chloride, okay, where magnesium came from the magnesium metal and chloride came from the hydrochloric acid. Okay, so if I write it down, maybe it's clearer. The acid is made of H plus and Cl minus, right? Here this is Mg. Okay, over here this is Mg Cl2 and this is H2 gas. So you can see, where did my hydrogen ions go to? It forms your hydrogen gas. Okay, step 2, we write down the chemical formula. Okay, I actually just wrote it down just now. Then now we want to balance it. Okay, remember that hydrogen gas is H2. We want to balance the equation. So first, which one should I multiply by 2? Okay, I should multiply hydrochloric acid by 2. Is it balanced now? Okay, yes. So now we add in state symbols. So what are state symbols? State symbols tell us what state the compound is in when it is reacting. Okay? For all acids, it must be in the aqueous state, as shown from the previous demonstration. If acids are not dissolved in water, they do not exhibit acidic properties. Okay? Magnesium is a solid because metals are usually solid at room temperature, right? Magnesium chloride is a soluble salt, so it will be dissolved in water. So to write down the state symbol for this, you must know the solubility of salts. Whereas hydrogen gas is a gas, so we write G. Okay, so just to write down all the state symbols for you and what they mean. Okay, AQ, it means aqueous. Whenever someone says that something is dissolved, it means that it is in the aqueous state. Okay, S is a solid, L is a liquid, and G is a gas. Okay, don't worry if you can't get the state symbols now. We'll have a lot more practice on this as we move along this chapter. Okay? Now, try it yourself. Write down the balanced chemical equation for the reaction between sulfuric acid and sodium metal now. Okay, I've helped you by writing down the products. Okay, now let's try and go through the answer. First of all, we need to write down the chemical formula of all these products, all these reactants and products. So, check, did you have the correct chemical formula? Now we have to balance this equation. So, looking at the equation, what am I missing on either side? Sodium, there's 2 on the right hand side and only 1 on the left hand side. So sodium must times 2. Now I check again, is it balanced now? Yes, it is. And I add in the state symbols. Okay, don't worry if you got the state symbols wrong, just try it now. Okay, sulfuric acid is in aqueous state. As mentioned, acids must be in aqueous state. Sodium is a metal, so it's a solid at room temperature. Sodium sulfate is soluble in water. And hydrogen gas is again a gas. Okay, now we move on to the second acid reaction. Acid and metal carbonate gives me salt, water, and carbon dioxide. How do we know that this has occurred? Same thing, we do an identifying test for the carbon dioxide gas. Okay, so do you remember what's the identifying test? Yes, it was to bubble the gas into lime water. Okay, remember that calcium hydroxide is actually your lime water. Here, calcium hydroxide is your lime water. Okay, this white precipitate form, do you remember what is this? This is actually your calcium carbonate. Okay, remember the equation? Okay, so this is your white precipitate. This is a solid. So how do we write a balanced equation? Let's say hydrochloric acid reacts with sodium carbonate. It will give me the salts sodium chloride, water, and carbon dioxide. Now, water and carbon dioxide, I know for sure you can write. Okay, but how do I know it's sodium chloride? Again, the metal from the metal carbonate, forms the cation of the salt, whereas the chloride came from the acid. Okay, the carbon dioxide came from your carbonate. Okay, so hydrochloric acid plus sodium carbonate will give me sodium chloride, water, and carbon dioxide. Can you try writing down the chemical formula of all of them and balancing the equation now? Okay, now let's check your answers. This is the correct chemical formula. Okay, check that your chemical formulas are correct first. Now, let's balance the equation. So, again, I see that on the left hand side I have 2 Na, on the right hand side I only have 1 Na. So I multiply by 2. When I multiply sodium chloride on the right hand side by 2, I realize that the chloride on the right hand side is there's 2 of it, but on the left hand side there's only 1. Okay, so I need to times HCl by 2. Then check, is it now balanced? Yes, it is. And now I add the state symbols. Okay, water is a liquid at room temperature. Okay, so that's why H2O I write L. Again, carbon dioxide is a gas, so I write G. Sodium chloride is a soluble salt. Okay, it's a table salt. Remember, if you put salt in water, it dissolves. Yeah, so sodium chloride is also aqueous. Check, did you give the correct chemical formula? Is it balanced? Are the state symbols correct? Now, write down the balanced chemical equation for the reaction between nitric acid and calcium carbonate. I have helped you by writing down the salt that will be formed. Okay, again, the cation comes from the metal carbonate and the anion comes from the nitric acid. So this is the correct chemical formula, and this is the balanced equation. This is the state symbol. Calcium carbonate is a solid and is insoluble. Okay, that's why you have your white precipitate. Check, do you give the correct chemical formula? Is it balanced? Are state symbols correct? Now, we move on to the third acid-base reaction. What is a base? A base is a metal hydroxide or metal oxide. Okay, so long as it's a metal hydroxide or metal oxide, it is a base. For instance, give me a metal. Okay, say magnesium. Okay, magnesium is a metal, so magnesium hydroxide is considered a base. Okay, another metal, let's say copper oxide, it is also a base. Okay, most metal hydroxides or oxides are insoluble though. There's exception to this, which is your except group 1 hydroxides or oxides. Okay, now let's move on. How do we know an acid-base reaction has occurred? Okay, try and think about it. I actually gave a hint at the start of the video. Okay, we can tell that an acid-base reaction has occurred by using pH indicators. For instance, we can use your universal indicator, which changes color according to the pH, and we can also use your litmus paper or other pH indicators like methyl orange or phenolphthalein. Okay, don't worry about pH indicators yet. We will learn more about them in under the chapter pH indicators. Okay, so now acid and base gives me salt and water. So can you try writing down the word equation as well as the balanced chemical equation on your own now? Okay, so first we must identify what is the salt that's being formed. How do I know what's the metal cation? The metal cation will come from my sodium. Okay, so my metal cation will be from here, and my anion will be my sulfate. Okay, so I'll form sodium sulfate and water. So sodium is here, sulfate is from here. Okay, and this will be my balanced chemical equation. Okay, check. Did you have everything correct? Now, do you know why NaOH, even though it's a metal hydroxide, I said that it's insoluble, but here is in aqueous state? It is because Na is in a group 1. Okay, so group 1 hydroxides are soluble and hence they are in the aqueous state. Now, let's think. What forms the water in this reaction? Where did the H2O come from? Okay, if you look at just the equation, you should be able to see that since here there's no H and O, all the H and O on the left hand side went to form the water on the right hand side. Okay, so what forms the water in this reaction? It is actually your hydrogen ions reacting with your hydroxide ions to give you a water. Okay, so this is the case where two ions came together and form a covalent compound. Okay, so remember this is covalent. Okay, but these are all ions. Okay, so if you notice in this reaction, I'll use up my H+, which is what gives an acid its acidic property, right? So this is known as a neutralization reaction. It neutralizes the solution. It becomes neutral. Okay, because what we form on the right hand side, has no, is not an acidic or basic compound. Okay, so on the right hand side, this is neutral. Now, why are there three? Okay, so here's a summary of the three general chemical equations. Acid metal gives me salt and hydrogen gas, what we did in the lab. Acid and metal carbonate gives us salt, water, and carbon dioxide. We also did this in the lab. Acid and base gives me salt and water. Okay, now, you can try and think of some mnemonics to help you remember the general reactions of an acid. For example, acid metal gives me salt and hydrogen. I can remember it as a mad stupid hyena, AMSH. Okay, so you can try and think of ways to remember the acid reactions yourself. Now, back to the story. Okay, so why did the Germans use the chlorine gas during the war? What happened was your chlorine gas will react with water to give us HCl. Okay, so this is what will happen when chlorine gas react with water. Okay, it will give your hydrochloric acid. So what happens is when we breathe in chlorine gas, the water that's lining our respiratory tract will react with chlorine and form hydrochloric acid. Okay, and this will start to corrode the respiratory tract. Okay, even though chlorine itself is not an acid, okay, but it reacts with water to give an acid.